let's investigate some integration problems. So we need to find the shaded region. Because how can we do that? Well, we don't have a function, so we need to create some sort of function for my problem. So in this case, I'm given a straight line. Very simple. I'm given a y-intercept, so I can already say +3. I'm going to write this in slope-intercept form. And then if I look at this, I can see, well, I go 3 slots down and 4 slots right. So I have my rise overrun. So I can say -3 over 4x. This should give me my slope-intercept form. If I cross multiply, I get 4. So yes, I can calculate an x-intercept. Okay. So here we have our function. The f of x is equal to -3 over 4x plus 3. Okay, so what do we do now? Well, now we can write an integral. An integral for -4 over 3x plus 3 dx. And we want to find the area under this shaded region, so it's going to be from 4 to 0. So now we need to integrate this. Well, how can we do that? Well, for now, we can just use our simple form where we have x n plus 1 over n plus 1, or this technique. So in this case, I'm currently x, so we can say, well, in this case, it's going to be -3 over 4x squared. The 2 goes down, so this gives me times 2. So that's going to be plus 3x. So now I have -3 over 8x squared plus 3x. Okay, so I found my integral. Now I want to evaluate it at the points 4 and 0. So now, how do we evaluate this? Well, we can substitute our 4 and our 0 into our function. Our new function, our integrated function. So we get -3 over 8, 4 squared plus 3, 4. And we want to subtract this initially from 0. But I will write everything out just so we can do the full work. 0 squared plus 3 times 0. That's going to give me, I need to grab a calculator. So let's say -3 over 8. We're going to multiply this with 4 squared plus 12. That gives me 6. Okay, so my area is 6 units squared. Well, is there any way to evaluate this? To see if this is true, 6 units squared. Well, let's analyze this question actually. So if I go from 3 to 4, I have 4, I have 3. Is there any other way we can find this? Well, there is. I'm doing a little bit of an in-depth analysis now, so if you want to, you can skip to the second integration problem. But for now, we want to find the area of just shaded region. This is very similar to a triangle. Not it's very similar, it literally is a triangle. So what we can do is we can find the area of the triangle in this case. Since it's a known shape, we know the area of a triangle is half of the base multiply the height. The half of the base is 4. So it's going to be 1 over 2 multiply 4 times 3. That gives me 2 times 3, which is then equal to 6 units squared. So in this case, my evaluation is correct. My final answer will then be 6 units squared. Well, what about the next one? Well, the next one, you should be able to say what the function's name is. Well, this function has a name of f of x is equal to x squared. This is a parabola. Now, it would make perfect sense to be a parabola, maybe not on this picture, but both sides are symmetrical. Okay? There's an equal distance between the 2 points. I mean, maybe not in this case, but in general, you'll able to notice a parabola. And we have no vertical shift, meaning I don't have some +2 where my parabola starts at a higher point. So I can therefore just say, well, it's 0. So x squared Okay, so now we can place this inside of an integral. 2, we want to evaluate it at the points 2 and 0, dx. So how do we integrate this? Same way as earlier, where we have x squared. So in this case, it's going to be x3 over 3. How did I get this? Well, very simple, x2 plus 1 over 2 plus 1. Okay, so I found my new function. And then I want to evaluate it at the points 2 and 0. So now I can say, well, the f of b minus the f of a, remember, we're using ba. So we can therefore say the f of b minus the f of a, the upper function and the lower function. Okay, so very simple. What we can do is we can substitute our values. So the f of b is going to be 2, excuse me, 2 cubed over 3 minus 0 cubed over 3. That gives me 8 over 3 units squared. 8 over 3 units squared. Okay, so there's my answer for number 2, 8 over 3 units squared. Unfortunately, we can't really test this any other way, since this is an unknown shape. Look at this. I mean, I guess we can with derivatives, but I'll get to that in another video. So let's go to this function. Well, this function looks familiar to me. I should have added a point there. Let me add a point 1. Okay, let me add a point over here. So usually it might be given as 1.5. So it doesn't cross at 1.5, but yeah. So I'm going to write this integral over here. Let me redraw it quick, since I'm running out of space. Whoopsie, that looks very awful. But to those of you who are familiar with mathematics, trigonometry, integration, derivatives, you should notice that this very much looks like the f of x is equal to cosine x. We see no shift in our amplitude. We see no shift in our period. Why is that? And our wavelength resembles pretty much a straight cosine function. So how do we know what this point is? Well, this is where your knowledge should come in, where we have the circumference of a full circle is 2 pi. So if we divide 2 pi by 4, we know that our cosine function crosses at pi over 2 on my x-axis. Okay, the first cross. If you didn't know that, I would highly recommend that you review, especially for integration and derivatives, you review the unit circle, since it plays quite a fundamental role all around, especially when you get to trigonometry and calculus, or trig identities, right? Anyway, let's continue. So we want to find the integral of cosine x dx. Sorry about that, ladies and gentlemen. Somebody came into my house unannounced. Anyway, so we had this function where I mentioned it was a cosine function. If I'm going to repeat stuff, I'm sorry. I lost completely track of what I was doing. Anyway, so this was pi over 2. This is a cosine function. It crosses your x-axis at the first point when we divide our full circle, as I mentioned, into four sections. So the period, it's known as that. Anyway, so we're going to evaluate this integral. We have pi over 2, 0. Now, let's say we have cosine of x dx. The antiderivative of cosine is the sine of x. So now I want to evaluate it at the points pi over 2, 0. So I can rewrite this as the sine of pi over 2 minus the sine of 0. Now anything multiplies 0, in this case sine of 0 is also known as just 0. Okay, now this one's a little bit tricky. This one is tricky. This one is pi over 2. Okay, but if you type pi over 2 in on a calculator, now that's a very common mistake, okay? Don't be fooled. So if you type in sine pi over 2 on a calculator, what do you get? Let's see. You get some 0.2741213359. Now some students might write that as the area, but no. First things first, we want to go from radians to degrees. Okay, so how do we go from radians to degrees? We take our radiant value. Radians just mathematical communication for angles. Makes equations a little bit easier. And we want to multiply this with 180 over pi. The 2 pi's cancel out. We have 180 degrees, excuse me. So it's going to be 180 degrees over 2. And then this gives me 90 degrees. And if we go back to our unit circle, we can see, well, at this point is my 90 degrees. Okay, since this is 0, and we're moving, this would be 90. So this coordinate on my unit circle, if I'm talking about a basic sine and cosine function, this is 0, 1. And my x coordinate is related to cosine, since it's adjacent over the opposite, adjacent over hypotenuse. And my y coordinate is related to my sine. So my sine of 90 will be evaluated as 1, and my cosine of 0, or cosine 90 is equal to 0. So in this case, we can say, well, 1 minus 0, you don't really have to write this, which is 1 unit squared. So this would be the area underneath my curve. Yeah. Okay. I'm going to have a new blank page for the next one. Now, I can rewrite this using the property of integrals, where I have 4x plus 2x squared plus cosine x dx. Now, I can break this up into 3 separate integrals, where I can say the integral of 4x cubed dx plus the integral of 2x squared dx plus the integral of cosine x dx. It just really depends on who your educator is, right? Like, let's say your teacher is a rigorous math teacher, like in-depth sort of like mathematical king. Anyway, so we evaluate this one earlier, which was x, right? Yes, x to the 4 plus 2x we want to evaluate it at the point 4 and 1. So in this case, we can then say, well, if I take 4 raised to the 4 plus 4 raised to the 3 over 3 plus the sine of 4, and I want to subtract this from 1 raised to the 4 plus 1 raised to the 3 over 3 plus the sine of 1. If I do this, I get 897 over 3 minus 5 over 3 plus the sine of 4 minus the sine of 1. And then we can evaluate this as 297 plus the sine of 4 minus the sine of 1. And we can leave it in this answer, units squared.